it's my pleasure to announce the next paper. The paper has the title Hybrid Pointing for Touch, Switching Between Absolute and Relative Pointing on Large Touchscreens. And this work is presented by Terence, Dickson, Rina, Wehbe, Fabrice, Matulic, and Daniel Vogel.
Hello, everyone. Thank you for joining me, Rina Wehbe. I'm second author on this paper, and I will be presenting Hybrid Pointing for Touch, Switching Between Absolute and Relative Pointing. In this paper, we introduce CursorTap, which is the technique shown below, a hybrid interaction technique for wall-sized displays. We also present a validation of the technique in 2 experiments presented in this paper. In the first experiment, we compare CursorTap with a drag technique that we will introduce in the following slide. And in the second experiment, we introduce players to the techniques within a game setting to see if they would naturally use these pointing techniques. Reaching digital objects on large displays can be difficult because large displays are large. So for users who are short, not that I count myself among that group, reaching a digital object all the way at the top of the display might be out of physical range. In addition, these digital objects are spread out throughout the large displays, so it can be very difficult to stand in one place and assemble all of the information you need. Additionally, there are lots of problems with reaching and fatigue from moving around. And often users who are sharing a display don't want to be crossing into each other's boundaries. So we looked at how we could enhance pointing and reaching on large displays. And I want to clarify, when I say large displays, I'm talking about wall-sized displays. The display used in this study is over 4 meters long. Some background. User comfort while reaching is something that we've been looking at for a while. We know that Shoemaker et al. In 2010 had a study where they looked at the twisting and the turning in order to reach objects. Wall input techniques have been tried to be improved by many of us, where we're either looking at the hybrid pointing paper by Forlines et al. In 2006, which inspired many of the techniques in this paper, was designed to support mode switching. The technique uses a pen input and takes advantages of the affordance of that display. The device tracks the position of the pen even when lifted or hovering above the display. The interface can also follow the user. So for our technique, the design goals were to be intuitive, have low complexity, efficient, and allow for multi-user touch on the display. We wanted to make sure that there was a low need for software support and hardware support. We contrasted this against our hybrid pointing for touch. Now, our hybrid pointing for touch technique is what we ended up using in the second study. So I'm going to take a little bit of time to explain the importance of this technique. So as you see, the first author, Terence, here, is placing more than 3 fingers on the display. After placing more than 3 fingers on the display, we see the appearance of a larger circle or a dead zone. This is important because it stops us from detecting another finger input as part of the same hand. Touching with the other hand outside of the dead zone creates a cursor, which then you can use to drag across the screen as part of a distant reaching technique. And then you can see him tap in order to simulate a click. So looking at that in slow motion, we'll see that on the left hand, multiple fingers, more than 3, are used to create a dead zone. Then on the right hand, 1 finger has been used as creating the cursor outside the dead zone. And then he moves his right hand with the 1 finger touch point as a cursor and then taps to simulate a click. Both experiments used the power wall at University of Waterloo. The power wall consisted of 8 different displays tiled together. Over top of the displays, there is a clear overlay And on the border of this overlay, we have the touch apparatus consisting of one-dimensional array of sensors around the edge of the screen. Touches are detected as shadows on the infrared lights. This is a very affordable way to create a large display, but does have some setbacks, which we discuss in the paper. So again, the purpose was to evaluate performance of techniques. The techniques tested were CursorTap, drag, and absolute. We logged all the trial information for participants, between the technique evaluation of speed and accuracy, and we also looked at whether or not the participants preferred any of the reaching or distant techniques. You can see on the left a conceptualization of the study, and on the right a video of me performing the task in the study. Participants were asked to stand in either of these blue squares. We did this to maximize use of the display. While standing in these squares, they were asked to either use absolute or relative to acquire the red target. So if you'll see here, I'm using a long reaching for the red target, but when it is closer to me, I will use the direct interaction technique. For experiment 1, we looked at learning, error rate, technique by width and distance, selection time, and subjective ratings from the user. We were particularly interested in mode switching between absolute and relative, as you can see on the right-hand side top figure. Users generally used absolute and relative based on the distance they were from their targets. And we can see that the error rates for CursorTap were appropriate for the mode that we had presented. So going forward, we use CursorTap in the second study. So where experiment 1 served to validate the technique, experiment 2 asks, will users use this technique voluntarily in an open-ended setting? We use a game as our open-ended setting because it increases the ecological validity of the study. Users could choose whether or not to use absolute or relative reaching tools within the game. And there were advantages for being able to use both, mainly that you could target enemies both on your side of the display and the competitor side of the display. The game is a Space Invader style trope with 2 players. In the game, participants are tasked with defending Earth from invading enemy forces. Participants must work within their spaceship or workstation represented by the rectangular areas. Each tool represented a different technique that we wanted participants to be able to use. The Earth here would lose health if enemy dots here were to crash into it. So participants had a cooperative goal, which was save Earth, in both the cooperative and the competitive condition, which differed basically on whether or not the scores were combined for both players or separate for each player, showing which one was the better defender of Earth. So we wanted to look at these different interaction techniques. So each of these interaction techniques were represented by weapons. They're available in both absolute and relative modes. So the first technique is the cannon, which was represented as red or sort of this orangey color. And the red cannon would be tapping on the display. Again, you could use an absolute method to tap on the target or spawn a long-range cursor using CursorTap, one hand down on the display with more than 3 fingers to create a dead zone, touching outside of that dead zone, and then using that cursor to tap on enemies from a distance. The second, the green shield, it represents a dragging motion. So again, it can be used in absolute and relative, and the idea is that for the oncoming enemy, you would drag to block the enemy from getting to the Earth. Finally, the blue tool, again, available in absolute, where you can just tap and circle, or relative, where you put one hand down, more than 3 fingers, one hand outside the dead zone, and then circle, created a lasso tool or a black hole for capturing enemies and defeating them. So our main question in study 2 is, would people choose to use the relative techniques or the absolute techniques alone? So we looked at other things. We found no learning effects. For this study, there was no difference between cooperative and competitive for either technique. And we found that people did choose to use this long-range touch mode. Participants only missed a few enemies in general, and we found that we were able to maximize the data without being unrealistically easy in this game format. Most enemies eliminated at distance were using this long range or relative touch modes. In general, there was a preference for a relative technique because of fatigue and speed, and absolute for accuracy. The black hole or the lasso tool was preferred for all three different techniques, so they liked it more than the shield or the cannon. So in summary, we present CursorTap, a bimanual multi-touch hybrid pointing technique for large displays that supports absolute and relative pointing. Our combined results from Study 1 and Study 2 shows CursorTap is an effective technique for reaching distant targets and outperforms standard absolute touch input or dragging the entire display window. Few interaction technique papers present both the closed controlled experiment and an open-ended choice-based task. We believe the results of our second study strengthens our methodology by validating the potential for CursorTap in real applications, not necessarily only in games. Based on our results, we believe CursorTap can be effectively used in large display contexts where both spatially close and distant access to content is required. For example, collaborative applications for visualization or data exploration. Throughout the presentation, I hinted that there was another study which relates to this experimental setup, which looks particularly at the screen real estate and territorial understanding between the players. In this second study, we focus more about the collaborative and competitive environment in which players play the game. Please check out our paper at CHI 2020 for more information about these results. So you've just seen hybrid pointing for touch, switching between absolute and relative pointing on large touch screens. My co-authors and I, Terence Dickson, Fabrice Matulic, and Dan Vogel, are happy to present our work. And also I, Rina Wehbe, would like to say that I'm hiring. So if you're interested in this research, if you liked work on territoriality, or if you're interested in creating immersive computing environments and public computing spaces, I would love to work with you. So please apply. I have postdocs, PhD student position, and always collaborator positions open. So thank you again. My name is Rina Wehbe. Heard hybrid pointing for touch. At this time, I'm happy to take any questions. Thank you.
Thank you so much for this excellent talk. You know the drill. If you have any questions, post them into the Zoom or just keep asking them out. And until we get the first questions in, I have a very general question about activating the relative mode. You said that you are using 3 fingers that you put on the screen to activate the relative mode so you can start doing the pointing gestures. And I was asking myself, why 3 fingers? Why not using another gesture like a fist or maybe a voice assistant that does this relative activation?
So our design goals were to have as little overhead for participants, like not needing a pen, not needing to have, voice interpretation or be in a quiet space in order to hear it, and to memorize as little gestures as possible. So what we wanted to do was we wanted to create implementation of the mode by using two hands. So one hand down on the display sends 3 or more fingers, so you could use all 5. And the other hand outside of the dead zone, which was characterized as these touch points belonging to this hand, triggered this long reaching mode. Or for participants to be able to remember like the tools or how to use them, it was easy. It was always one hand down, one hand outside, use the tool. So it became really easy for them to pick up. And when we wanted them to switch tools, that actually was facilitated in game. So they would drag over a tool into their workspace from the shared tool area.
So I was asking myself when you were exactly showing the gesture of the 3 fingers, why people don't use like pointing gestures, you know, like tracking where you point at the large display, because from my perspective, this would make much more sense to interact with a display, but probably there are other limitations such as using a tracking system and so on. So what's your take on that? Why not distant pointing? Why do I have to stand in front of the screen and touch the screen?
So this study was run pre-COVID when multi-touch large screens were kind of more in, I guess, a la mode, more in fashion. You know, we really kind of just considered that people would walk up and use the display with friends. So in public spaces such as movie theaters, sometimes you'll walk into the movie theater and you'll see like a promo game, a large screen, you know, and then multiple kids were playing this promo game, like for example, Kung Fu Panda. However, then COVID-19 hit, it definitely brings up more questions of, well, how can we eliminate the shared surface? And of course, who's going to sanitize this surface now? And that sort of similar questions. But I think this is really a paradigm shift in thought for us as researchers to start thinking, oh, let's not have people walk up and touch the display. Let's have them at a distance, because everything's been at a distance for the last 3 years. But definitely something for future research. In my work now is going to be looking more at interacting with like a bring your own device or mobile, because nowadays when we're looking at these shared large surfaces, we're no longer anticipating multiple touches on the display because everything has to be, you know, wiped down with sanitizer all the time.
Yeah, I see. Yeah, I get that problem. Are there any questions from the audience in the meantime? Then I would like to close this talk with one last question. So you have shown that your work was building upon previous work, then you did an iteration on this, presented an improved version. What are now the next steps for your work?
So I actually am really glad you asked this question, because I do have another paper at CHI 2020 that is published. So it looks at territoriality and screen real estate and how we understand spaces within the large display. How do we get this, you know, collaboration? What space is considered your space? And in that paper, we actually looked at dynamic or floating workspaces, not just anchored workspaces. So being able to move your work around the screen. So taking your spaceship around and going to other places. And a lot of that work was really interesting because we found out different things about how people think about tools and use the space, when people feel it's reasonable to interrupt someone else when they're using the space, and whether moving over to the display physically or digitally was preferred. Now, spoiler alert, even before the pandemic, digital was seen as a less disruptive reaching method. And now post-pandemic, I'm very sure that we'll find that as an even stronger, you know, result. But of course, replicate, replicate, replicate. That's all part of science, so I encourage that. And future work in this area really is going to look at not just the combination of different techniques for use, touching, and being able to have floating workspaces, but I think really some of the way that we're going to go is going to be this bring your own device paradigm, because again, we're limited now for, if we have a display in a public space, it's very noisy, it's very loud, there's a lot of things to sense, and even, you know, I hate to say it, but computer vision isn't going the way we all expected it in the last 10 years. So we're going to have to look at different ways for identifying our user and seeing those contributions to the whatever application as displayed on the large display as well as on the mobile device for the user. So I have a lot of interest in this hybrid bring your own device paradigm for large displays and public computing. And in case you didn't hear, I'm looking for collaborators. So yeah, thank you so much for your question.
All right. Thank you so much for your talk, and thank you so much for this exciting Q&A. Let's give Rina a round of applause, and also a round of applause to all of our speakers who did an excellent job presenting their work. Thank you so much.